the idea that we've looked at curves for a while. And so if I'm given a curve like that, I want you to try to tell me what the rate of change is at given areas of the curve. So if I wanted you to say, hey, what's the average rate of change from here to here, from those 2 points? What would you do? Find the slope. Okay? So just like you've done with linear stuff, so we've looked at, okay, here's my slope, and I've got some sort of a line. You grab 2 endpoints, we'll look at rise over run. You're going to do the same thing with curves today. You're going to go, okay, given this interval from, let's call that x equals 1 to x equals 3. I want you to go ahead and find what my average rate of change is. And so you're going to just take these 2 points, draw a line through them, and you're going to figure out what the slope of that line is. Okay? So let's, the first few questions you'll see in your homework will just give you the points, but it'll ask you for the interval, so you're going to go find where's my x value. Okay, use that coordinate point. Where's my last x value? Use that coordinate point. Ones later on are going to actually give you some equation. And I'm going to see if I can remember the one I built yesterday because it actually worked pretty well. Minus 2x squared plus 3. We'll see if this works. I may just totally be making up numbers right now and not have it work. Anyway, so let's say that's my equation. I know it's some sort of a cubic equation because of the way it's kind of curved and it's behaving. And so we'll see, does this work? Which your later problems in the homework are going to just say, from the interval given this equation, tell me what the rate of change is. How do you think you'd go about doing that then? So this would say, what's my average rate of change given the interval of 1 to 3? That's how it'll be phrased. What could I do? Do I know what those 2 green dots are yet?
Points on the line.
They're points on the line. Which, how can I find that, Sean? Excellent. So I'm going to take my first value, 1, because that's the beginning of my range, plug it in for x. So in this case, we'll end up with 1 cubed minus 2 times 1 squared. So 1 minus 2 is negative 1, plus 3 is 2. So this coordinate point is 1, comma 2. Cool. Okay. Do the same thing for 3. So if I plug 3 in now, so we'll take our end point, plug it in for x. 3 cubed is 27. Minus 2 times 3 squared, which would be 27 minus 18, which gives us 9. Plus 3 is 12. So this coordinate point would be the coordinate point 3, comma 12. Cool. Now how can I find slope, or the average rate of change? We'll just do our rise over run. So we have our change in y over our change in x. And so in this case, we notice that, oops, that should be an x. So in this case, we'll notice that our rise goes up 10. Our run is 2. So our slope in this case is 5. Cool. Okay, that's our average rate of change. That's what you'll end up doing. Handful of the ones you'll see on tonight's problems are going to have points that are like on opposite sides of these peaks and valleys. And so your average rate of change is actually going to end up being 0. Because your rise will be 0. Okay? So you could have an average rate of change of 0. Just know that that is a possibility. Let's see, what else we got? That's kind of what we're going to do for the majority of the night. Anybody want to see how to do this with calculus?
No.
It's really fun and easy.
No.
Have you guys done derivatives?
Yes.
You've seen derivatives? No. Okay. All right. I'll show you guys later. This is all you need to do. Anybody know what the name of that line is, actually? Let's talk about that. What's this? No, not that line, but the line we just drew, the green one. We call it I heard tangent and secant. Which one do we think it is? Tangent goes through how many points? 1. So this is a tangent line here. That hits that 1 point. Okay. So let's call that point at 2. Okay. So the green one is called a secant. Okay. So if it touches 1 point, it's a tangent line. If it touches 2 points, we'll call it a secant line. Anybody know how to find the actual tangent line? You don't have to.
No.
You use the derivative. It's pretty cool. So, anyways, secant lines are basic, right? Those are an estimation. I can find an average rate of change. If I want to find the instantaneous rate of change, I can find this tangent line. So, yes?
Question. So, when you do your derivative, since there's a 3 there, do you just get rid of the 3 at the end? So would it be?
Oh, yeah. So I'll show you here in just a second. I'll actually do it because anybody who doesn't want to hear, I'll tell to tune out here for a second. So, anyways, basically what's happening, right, is I want to know roughly what that rate of change is, that tangent line. So we estimate it with 2 points because the math on it's way easier as far as just like the basic algebra stuff we've done. And then we get those points closer and closer and closer and closer together. What happens when my change of x's approaches 0, though? That denominator freaks out. So then we turn into the world of calculus and we have to use derivatives and cool stuff. So the idea of what calculus is kind of that idea of those limits as we approach infinity and zeros and stuff. So if you don't want to learn calculus right now, just kind of tune me out, but do so silently so those that are kind of curious how to do this can see what they'll do next year. So all you need to do to find this is you can find a tangent with your derivative. So if I find the first derivative of this y value, all you need to do is take your exponents and multiply it by the coefficient and then reduce it by 1. So this would become the equation 3x squared minus 4x, and then yes, Casey, because this is x to the 0 power, 0 times 3 is 0, so that piece will disappear. So here's my first derivative, and then I want to evaluate the instantaneous rate of change at 2. Let's say that's what it is between 1 and 3. I can plug in 2 for my x values. So my instantaneous rate of change is going to become 3 times x squared, which would be 3 times 4, minus 4 times my x value, which was 2. And so I'll end up with 12 minus 8, which is 4. Okay? And so my perfect instantaneous rate of change is actually 4. And so we'll see as I bring these dots closer and closer and closer together, even though my average rate of change was pretty close, I'll actually get really, really, really close to what my true rate of change is.
How do you know to stop there and not to keep?
What do you mean keep?
Like keep going and go 6x minus 4.
With the derivatives?
Yeah.
The second derivative will help you find other stuff, and we won't get into that. But what's nice about this is you can actually find what these max and min values are because you can figure out where your slope is 0 because your instantaneous rate of change at the tops and bottoms will be 0. And so you can use our quadratic formula stuff to find where those 2 points would be using that stuff. So that's kind of fun. All right, that's some calculus. You guys all learned calculus this year. Woo!